Welcome to a tutorial video on C++. In this video I'm talking about objects. Object-oriented programming is much newer than the language C++ itself, so that functionality was added in newer versions of C++. It also uses a lot of complex ideas, and I'll try to walk through all of those here. So to start, instead of looking at the main file, I'm going to jump over to person. Person.h here defines the person object, and it's going to be used in the other main file. But let's walk through some of the ideas of object-oriented programming. To start, objects are ways of collecting data together. They relate to each other through two types of relationships. The first of which is a has-a, and the other is a is-a relationship. That is, an object can't have things. It has properties. It has data. It also can be other things. The is-a relationship isn't necessarily covered in this video, but those are the two types of relationships objects can have. The first of which will be the center of this video, the has-a. So objects can't have things. They have properties. When we talk about objects, we also talk about two different ways of thinking about objects and their data. That is, things can be private or things can be public. When things are private, that means they're just kept within the data themselves, or kept within the data within the object, that is. So an object can have private data that no other object can interface with, or it can have public data, which means that other objects are able to interface and work with it. So we deal with these two different types of interfaces, those that are private and those that are public. And these allow objects to relate to each other in different ways. And we mentioned the has-a, is-a relationship models. We're dealing with objects that in C++, we define them as having private areas and public areas. Let's walk through some code here. The first of which is the class keyword. I mentioned that object-oriented programming is newer than the C++ language. So the class keyword is one of a number of different keywords that's going to be introduced in this video. So a class defines the blueprint for an object. In the previous video, when I was talking about pointers, we talked about the blueprints for structs, the blueprints for structures. And we would define what it did and what it was, and then we could use it somewhere else. So objects follow that same model of structs we saw in the previous video with pointers. We could define a blueprint for what we wanted it to look like, what data we wanted it to have, and how we wanted it to do things. But then we used it in another sense. We created an instance of it based on the blueprint that we defined. So in this case, we have an object definition, and then we can have the objects themselves in another file. So in this case, we're using the class keyword and then the name of this object. The name of this object is person. Similar to when we were using structs in the previous video, this is now a data type. It is an object. So we can create data based on this data type of person. Similar to when we were using structs, that now becomes a data type we can use. So we see class person, and similar to everything else we've looked at in C++, the entirety of this is defined with an open and closing curly brackets. So we have a class person. Person is the name of a type of object now, and we have its entire contents in open and closing curly brackets. Now I mentioned the two different models, public and private, and you'll see those two keywords here. The first of which is I've defined the private area of this object. Starting on line 8, notice private and then a colon. And then I have two different variables here. The first of which is an integer and the second of which is a string. I haven't previously talked about strings in these videos. The string is a type of data, and notice I'm including the string library up here so I can use it within this. I'm also including the standard namespace, std, and so I can use string without using the standard namespace. And this is explained more within the blog post that's within the description of this video. There are more details about the relationship between those two different ideas of including the string library and using the standard namespace and how that reacts here. But the general idea and what helps us in this video is I have two different variables. First of which is int, second of which is string. These are both private, which means no one can access them but this object themselves. We can't get that data back out. What this allows us to do, though, is create data within that object, manipulate it in different ways, and create an API or functional access to that data through different means. So we see that as part of the public part of this object. We define the private part, what data we want inside of it, and then the public part of functions that relate to that internal data. This is a very, very common model of creating objects that hold its own data, special data that it only has access to, and then defines functionality for how to relate to that data. Ways we can get at that data, ways we can change that data, or ways we can pull it out or do something else with it. In this case, we see a set of different functions here. Now, I've mentioned in previous videos, especially the video on functions, all functions have return type. Now, void is also a special type of return type for functions. And what this means basically is that no value will be returned. It will be returned void. So in this case, we can send data in using the set ID and its parameters ID. The new ID will be set to the internal ID. We see set name follows that same structure. We send data in, we make a change, but we're not sending data back out. These two are setters. We are setting data. We can also look at getting and getters right here. I've defined get ID, and notice it returns an int, matching the ID of right here, an integer. Return a string, the string internal. Notice I've followed a naming convention of underscores here. Now this isn't official, but it is a common practice to define the data within an object using underscores for the variable names, so we know it's private. So looking at it, I can immediately tell this is private, and it helps me keep track of that mentally. Instead of having to look back up in the private section and check, okay, what was the name of this, whatever. A very common usage is to put underscores in front of it to let me know as a programmer this is private data. So we see 4 different functions here within public. We can set ID, we can set name, we can get ID, and we can get name. And each of these reacts in turn. With the 2 different sets, set ID and set name, we're using void because we're not returning any data. And for get ID, we're returning integers, and for get name, we're returning strings. So we have our object, person, and again, this is our blueprint. We're not defining the data itself here. We're just defining how it reacts to stuff. Very similar in the previous video of talking about pointers and structs. We're defining its structure, and we're defining how it relates to things. So we have an object named person. It has internal data, private data. It also has public interface here of 4 different functions. We can set 2 things. We can get its data back out. And that defines this file. Again, we have a blueprint. We're not setting data. A blueprint for how we want this object to work when we create it. So let's go create it. Jumping back over to main, we see the first thing I'm doing right here is I'm including the IO stream so we can do some input-output. I'm also including, in quotations, person.h. So we're including that file back again. Because we're using the standard namespace, I'm including that right here using namespace standard, which means this file and this file are in the same namespace. Again, there's more details within the blog post that's linked out to in the description of this video file, but basically this allows us to use things within the same namespace. So we could use different namespaces to look at different things, but in this case, all the files are in the same namespace. They're in the same group, basically. So moving on from that, we see similar to in the previous video when I was using structs, I defined a blueprint and then I created an instance, created a variable based on that blueprint. We see right here, we're creating a new person object, Dan, based on the blueprint of person. Blueprint of person is coming from person.h. It's defined over here. So setting Dan here. Then we're using dan.setID, dan.setName. We saw this same grammatical pattern when we're using structs. When we're getting the data inside of structs, we're also using this dot notation here of the name of the object, dot, and then something inside of it, the properties inside of that object, or the data inside of that struct. The same thing we just looked at in the previous video of using structs. So the name of the thing, dot, the thing inside of it. So in this case, set ID, we're sending data into this. Set name, we're sending data into this. So over here, setting the ID and setting the name. And again, these are voids, so we're not returning any data. We're just sending data in and changing the internals of this object. So we see here we can create a new object, we can use its functionality that's with public, and we can get data back out. Now I've used this special see output style streams so we can work with different data types. And I'll move this over so we can look at this. And we see the ID is 1234 and the name is Dan, which is what we expected to see. I'll move this back. And so we see here using get ID and get name, we can then get that data back out of the object. So let's review all of this. I talked about how we create objects using the class keyword. Similar to when we're using structs in the previous video, everything within this is defined with an opening and closing curly brackets that defines everything that's within this object. By defining a blueprint for an object, we are defining a new data type. So we can then create variables based on this data type. So using the class keyword and the name of the object, in this case person. Within this, because it's an object, it can have both private and public areas. It's not necessary that they have both. It can in fact just have private areas. But an object with just private areas is not particularly useful because it can't really do anything. It can't interact in any way. In this case though, we had both private and public. Private contained the data, ID and name, and I was using the convention of using underscores, but this is not a standard way. This is just a personal convention that helps me identify that these are private data. Then we were looking at the public interface using the public keyword, and we had 4 different functions. Using set ID, we can change the internal ID. Using set name, we can change the internal name. Using get ID, we can get that ID, and using get name, we can get that name. So we have 2 different sets of things here, 2 different ways of setting the data and 2 different ways of getting the data, setters and getters. A very common programming pattern you find in many different languages. And here I've defined it here of just writing these names. 2 different sets to change the 2 different things, 2 different gets to get that data back out. Very common patterns. So we've defined this blueprint for this object, but we didn't define what its data was, just what it was, what it held, and how it was to do things when we used it. Over here in main, we included that file, include person.h, and this is person.h. We made sure everything was in the same namespace. Again, more details in the blog post. And then we came down here, we created a new person object based on that blueprint we already had. Then we used its functionality, its public functionality, following the same pattern we saw with structs. The name of the object, dot the thing inside of it. In this case, name of the object, Dan, dot set ID, which is a function, and so we're sending data in. Dan, dot set name, sending data in. And we can we can get that data right back out again using the name of the object, what's inside of it, in this case the get ID function, to get the ID back out. Name of the object dot what's inside of it, get name to get that name back out. So we can define objects, we can interact with them through their private and public interfaces. Using their public interfaces, we can send data in, and using the public interface, we can also get data back out. Thanks for watching.